How you do, fellow kids? It's your temporary math teacher here, Caden Johnson. And so today we're going to talk about asymptotes. Asymptotes are these funky curved lines that never cross a certain line. Like this one right here. Let me get to the website. It's called Desmos. It's very cool. It's where you graph stuff.
It's
kind
also free.
It's like a graphing calculator, but it doesn't cost $120. To make one of these, boy, you gotta hit Y equals, I don't know, random thing. And you gotta hit X. And then boom. That boy right there, that's an asymptote. That boy right there, that's an asymptote. And also, with, as we mentioned, the Desmos, it's free, it's a graphics, it graphs, it's cool. Like, it's a better graphing calculator. You can color your lines in. Coloring lines, cool.
We'll be finishing up in the next couple of minutes and then coming back in the classroom.
Thanks, Mom. But, an exponential function, which is what I just showed you, is a function where the constant is increased by the value of x. X and y intercepts are where the function crosses over the x and y, axis. And the intercept is a value of which crosses the axis. To graph the exponential function, easy peasy. All you need is the value, you put in the value of x. So, yeah, we get y, which is going to be that, and plus, you don't cross the x-intercept, you cross the y-intercept, because nothing's crossing over here. You get this better mean angle. And you put in the number, for ours it's 69, or you could do, what is it, 34, no, messed that up, 34, and we have to put in another subsidiary because that messed up, and you just put an x, and then boom, exponential function, like that, easy peasy.
It never crosses the x-axis because it's going infinitely in one direction.
Yup. You can do it with your family, you can do it with your wife, you can even do it with your kids. It's simple. We're talking about functions and domain. So domain is the amount of x values. So let's take your Fortnite wins, for example, which is 0. That will be your prime domain. And it goes from 1 to 2 and all the x values into infinity. But next on the list is how we can use it to help our final rate of change. So this x value, or domain, is 1. So you take 1 and you subtract it, or you put it over what your probable Fortnite KD is, which is 2. Shoot, that was a compliment. Take that back. That would suck. You put it over there. You get your good old calculator. Oh, wait.
Take the juices. Drink your water. Poor people would kill for that.
Get out of here. We're trying to record.
Drink your water.
Don't worry about these homies. But, so you put 1 over negative 2. People, am I right? So, you get that, put it over that, you get that, and your rate of change is negative 0.05. I have no idea if that's correct. It probably is. And from there, you can also put things into functions, which make some people think it's easy to make a function, or you can even do a table, which is pretty easy. Tables are very easy to understand because if your x value is 2, your equation is going to be 24. If your x value is negative 1, your equation will be negative 2.
Which would mean that your 0.5 answer is right, because negative 2 divided by negative 24 is half. Well, it's like, yeah, half, and then negative 1 divided by negative 2 is half.
This man's right. And that's all for today, folks. And I think my applesauce is leaking. Fellow kids, today we're going to talk about parts of an exponential graph. So, we're first going to tackle minimum and maximum. This graph right here, which shows my Fortnite wins, maximum as well, if I could get technology to work, would be 8.667. I ain't trash. But now, if we do some flipping around like this, creating a new graph, but we're just going to leave these, we'll leave them, we get a minimum, which will be your Fortnite wins. I somehow have a point something of a win higher than you. Too bad. The minimum would be 7.333. So now we're going to talk about domain and range. This parabola has a domain of negative infinity to positive infinity, but its range is to 7.333 to positive infinity, because the y will not go below that point. And domain is for x's and range is for y's. That looks like Gaga. Now we're going to talk about intervals and where it's positive and negative. So this one's all positive because if it was negative, it'd be going down here. But you can show where it's increasing and decreasing. So when it's going down here, because you're reading like a normal person, because you ain't no weeaboo reading your heckin' manga and hentai, this is the decreasing side. But this side over here is the increasing side. It was calculated by the y's. Actually, no, it's calculated by the domain. Next on the list of things to go over with the graph is the end behaviors, which...
Okay, I'll take over from here. So, the end behaviors would be where
I really hope I die from this.
where y is increasing, so as x, so the end behaviors would be one each side. So it'd be for the left side, it'd be as x is decreasing because it's going up like this, and it's going to the left, which is the negative. As x is decreasing, the y is increasing. And then for this side at the end over here, as x is going to the right, where it's always increasing in numbers, y is also increasing. Next thing where we can go over is where it shows that it's increasing and decreasing.
I've already done that, young man.
Okay, I guess that's it for today then. So, let me show you how you could tell if a graph has been flipped, translated, and any type of transformations. See now, this right here, y equals x squared, is the original problem. See how it curves from here and it goes up. Now, here is a different problem with some more numbers added to it. Here are the two different equations. See now, a way to tell the difference is that if there's a negative, that means that it's going to be translated over the x-axis, which basically means it's just going to be flipped around. The forward depends on if it's going to be a vertical stretch or a shrink. A shrink would be that it's not going as vertical. A stretch would be that it's becoming more vertical. The +3 explains how much it goes to the right or left. If it's +3, it goes to the left 3. That's why the vertex is at -3 right here. If it was -3, it would be over here at +3. See now, and then also there's at the end -2. -2 at the end tells you whether it's going up or down. Unlike the left and right way with where the x is in the parentheses, it goes normally, where if it's -2 it's down, +2 it would be up. It all depends if it's in the parentheses, if it's going to go left or right, up or down.